losing weight, like that is now well understood. You get into calorie deficit, you lose weight. The hard part comes after that.
Obesity is in some ways, a lot of times called the disease of prosperity, and in some way, the world has been dealing with obesity for close to 100 years, depending upon which part of the world you look at. But there has to be some catch as well. So one biggest drawback is you have to be on it. The moment you stop, the effect goes away.
In the food industry, this is called the bliss point, and it's usually a mix of right amount of sweetness, right amount of fat, and right amount of salt, and also a little bit of umami. Right, all of it put together is where you hit the bliss point.
That's incredible. So it's a great example of environment design, right? So anyone who is struggling with weight loss, or a parent worried about the weight gain among kids, like what are the environment design changes you can make?
Both sleep and stress, underrated. People mostly focus on movement and nutrition, but if you don't pay attention to it, they become limiting factors.
Santosh, welcome to SparX.
Thank you.
Really looking forward to talking to you about science of weight loss. I think we all know that, either some of us have personally struggled with weight loss, or we definitely know people around us who struggle with weight loss. For some reason, weight loss seems to be so difficult. I know you and I have talked about this for pretty much throughout our Cure.fit journey. Cult is doing what it can in its own way to help with one aspect of weight loss, which is to enable movement. But as we know, it's not as easy as just being active. I think it turns out weight loss is extremely complex. So let's start here. I know maybe start with your personal journey. You were sharing just before we started that you lost about 25 kg at some point in your life. What was how did you gain so much weight, and how did you figure out a way to lose it, and more importantly retain their weight loss? Because a lot of people struggle, they tend to gain back whatever weight they may lose. So how was your journey of losing their weight?
Yeah, always been on the higher side in terms of weight. In my teen, probably around 15 years since then. And then I got into college. College is when it became even worse. Sedentary lifestyle. So end of my college, and I'm talking about year 2008-9 was my peak weight. That was at around 95 kgs. Right? And I think around 2010, 2011 is when I said, okay, enough is enough. I need to take control of this. And at some point I just said, okay, enough is enough, and started. Did a bunch of things, mostly habit changes, I would say. I didn't really get into calorie counting or anything like that, but just cut out sugar, for example, reduce eating out, for example, and mixed movement into my life, which is got into cycling big time. Everywhere any part of Bangalore I even went to work, was just with cycle, and got into running, bunch of things, and I was able to lose that 20 kgs.
Over what period?
This was about 1.5 years. It took for me 1.5 to 2 years for me to shed all this weight.
And reason you were able to retain that weight loss is because those habit changes was kind of permanent.
Yes.
Right.
And that is the prime reason, and that's the hardest part of weight loss.
Look, that part of weight loss journey is. And we find anecdotes of somebody who would have lost 10 kg, 20 kg, and very few people are able to retain. So it's great, you are an exception from that point of view. But we also know that for most people, it's a massive struggle. And to no fault of theirs, I think we have very, very complicated biology. And it's only now, I think we are starting to both understand the science, as well as, there seems to be a major breakthrough on the horizon in terms of GLP-1 drugs. We'll talk about that later. But first of all, why do you think weight loss is so difficult for people?
There are two parts. Losing weight, like that is now well understood. You get into calorie deficit, you lose weight. And people go through these cycles where they decide, okay, I'm going to make this change, and they get into calorie deficit and they lose weight. So that's not the hard part. The hard part is keeping the lost weight.
No, first, let's slow down. Let's first explain. What is calorie deficit? How does one create calorie deficit?
Yeah, so this is well understood in terms of all the consumption in, that is calories in, any kind of food that you take in, and then there is expenditure. And there are multiple ways. Just body for its regular functioning, which is basal metabolic rate, and that is one energy expenditure. And then there is purposeful exercise, which is what you do in terms of movement, multiple other factors. There is also effect of digesting a food, which is the thermic effect of food, and all of this together is the calories out part. And if you're in balance when the calories in matches the calories out. If you're in a calorie deficit when the calories in is less than the calories out. Right? And this is fundamental. I mean, again, first law of thermodynamics: calories in, calories out. We can talk in more detail. It's often used as an oversimplified way to shift the blame to the individual, but that's not the case. But it is true. The fact is that there is a calories in, calories out model, and as long as your calories in exceeds calories out, you put on weight, and vice versa, where you lose weight.
Right, and as you said, like this is the at some level very simplified model, technically accurate, but not useful because while if you can somehow force yourself to effectively, you're starving yourself, and you'll obviously lose weight. But a lot of other things are happening also simultaneously. Your biology is going for a toss, mood goes for a toss, and the moment you relax, you come back with a vengeance. Body almost compels you to retain, that the period of starvation is over, and you want to go back to the time of prosperity, and therefore you gain back that weight. So, but still, let's say, so what's the hard part in weight loss? Is it just, that discipline to create that calorie deficit, or other factors involved, during and post that weight loss? That why most people will struggle with this, for a very long period of time.
The initial part, usually there is some trigger for people saying, yeah, it is time for me to lose weight, and they generate that energy to get into calorie deficit for at least a few months. Typically, you look at any weight loss studies, the peak weight loss happens in the 6th month. That's when most people, in terms of as a cohort, maximum weight loss happens. And when you look at the 12th month, half of them would have regained the weight. And if you look at a 1 year, 2 year, etc., the control and the treatment groups kind of converge. So that's so this first 6 months, that a lot of people get through that phase where they end up losing weight. The hard part comes after that. And there are multiple reasons for it. One is they go back to their old habits, right? And if you look at what the net weight that you have is a function of multiple things. It's just a function of all the behaviors, right? And it is very hard. Behavior change is hard. So people go back to their old behaviors, and so they end up regaining the weight. That is one part. And the second part, which you brought up, the biology, right? And our body, especially the brain, actively defends against weight loss. So it almost launches a counteractive force that kind of multiple counteractive. We can discuss that in more detail of how the brain ends up doing it, but that makes it really, really, really hard. So it is two things: one, going back to your old ways, and second, your body actively defending the new weight.
So I think let's explain that part, because a lot of people don't realize. They think it's just a matter of willpower or discipline and so on. But understanding that, if you're, let's say, somebody who's 80 kg and somehow through sheer willpower, calorie deficit, you manage to lose 10 kg, your brain is basically actively plotting, there's something wrong with this dude or a girl, and I need to gain back as soon as I get it. So it's in some ways you are at war with your own brain. But why is that? Why is not brain happy losing that 10 kg?
A short explanation is mostly evolution, right? Which is, our ancestors were in a place where this was not needed. We were always in a place of scarcity. So our bodies evolved more and more to gain weight or gain energy. But there was no evolutionary need to defend against extra weight. Right? So that's a very short answer. So the whole science around this is what is called set point theory. Right? There is a body set point. And how you arrive at a set point, that's a separate topic. We can come to that next. But let's say you are at a particular set point. By the way, this is also debated. There are some people who say there is no set point, and this is all. But there is more evidence in favor of the fact that there is a set point that your body has. And this set point is regulated by the brain, specifically the hypothalamus in the brain, right? And hypothalamus, by the way, is one of those things where it regulates multiple things in the body. Amongst the multiple things which hypothalamus does in terms of regulation, it also regulates the body fatness, right? And the way it does this is via the leptin signaling, which is leptin is a hormone which your adipose tissue secretes. The more fat you have, more leptin gets secreted. That's this leptin is processed by the hypothalamus, and any time the leptin levels go down, then it raises alarm. makes you hungry in the short term. It increases the levels of the hunger hormones, the ghrelin and so on. But slightly more long-termish, what it does, it increases your motivation for food. That is, anywhere your attention goes towards food, especially high-calorie food.
Yeah.
And it also reduces your metabolic rate. So because it says I'm sensing starvation, and I need to like fight against the starvation. So I will make you seek high-calorie food. And I will reduce your energy expenditure, right? And this is what the hypothalamus in short does.
Yeah, and that's very important to recognize that, while, because let's say you have a wedding event coming up or a beach vacation, so through sheer willpower, you somehow control, lost weight, but now brain is going to make you extra motivated to seek that food, and there is, it becomes very hard to resist, beyond a point. And that's why, this rebound weight gain is such a, big phenomena. And this is because you're saying, whether we call it set point theory or homeostasis, that's how brain has evolved. That it wants to maintain things certain way. If you're about certain weight, let's say 80 kg, then brain believes that that's the right weight for you. If you somehow go to 70 kg, something's wrong, and I'm going to get you, do whatever it takes, but I'm going to get you back to that.
Yes, exactly. So that's and the interesting thing is the negative feedback loop here works. That is when the leptin signal goes down, the contracted measures come in, but the hypothalamus doesn't care about it going up. Right, and so that's why it doesn't, and there is largely evolutionary reason where there was no need for it to have any contractive measures when the leptin level goes up. So that is just because of evolution.
So Santosh, obesity is in some ways, a lot of times called the disease of prosperity, and in some way, the world has been dealing with obesity for close to 100 years, depending upon which part of the world you look at. And last, 40-50 years, there have been numerous studies. The biological understanding has improved, and there are two very prevalent theories that you were earlier mentioning. So can you talk about that? What is today's scientific understanding of the the science of weight gain and weight loss, and what are these two different camps?
People have been trying to figure out models of obesity, is what people call it. Like everyone recognized by I think around 60s, 70s, we are facing a major obesity problem. We need to start looking at it. So people are we're trying to figure out why are people becoming. So if you go back to the original, the previous point around set point, we said why set point body defends a set point, but why is the set point going up in the first place? Right? And as a population, our set point is going up continuously. Why is that happening is the question. First, the first explanation that came was a simple calories in, calories out, and that was quickly dismissed. Right? And the caveat here, the nuance here is the blame. You put the blame on the individual, saying you don't have willpower, and that's why you're. And it's not suddenly, as a population, it's not that we have lost willpower, right? In the last 40, 50 years, so that's not a good explanation for why people are becoming fat. Then and there are a bunch of single ingredient causing being the villain. So it could be seed oil, it could be fructose. Or it could be EDCs, the endocrine disruptors, etc., which is causing the obesity. Partly true, it is not, but there are enough studies which say, for example, the sugar fructose consumption, the last 20-30 years, after a very sharp increase till 2000s, has been flat in US, but the obesity levels continue to increase. So that's not a good explanation. Seed oil is also not a good explanation, although it does have negative health effects, etc., but that's not a major explanation. Where we are left with is two major competing theories. One is called the carbohydrate insulin model of obesity, and second is called the energy balance model of obesity. Energy balance model, I'll caveat it right away, it is not the calories in, calories out model. Though it sounds like energy balance, calories in, calories out, it is much more nuanced than that. Let me start with the carbohydrate insulin model of obesity. First, the takeaways are very common. Like if you look at what does the carbohydrate insulin model say in terms of lessons, like what do we need to do finally? It is not very different from the carbohydrate insulin model. And so for a layman, in terms of just what are the best practices that you want to say, it is very similar. Don't have refined carbs, for example. Eat more whole foods. And the general advice stays common between the two. But where it is different is coming up with a good mechanistic explanation for what actually happens. That is important because example is GLP, right? And if you want to design a drug for impact, then mechanism is important so you can design the right drug. In short, the carbohydrate insulin model says the reason why you're putting on weight, the causation follows like this. A little bit of, again, getting into technical terms, the major role is here played by insulin.
Yeah.
Maybe I'll take a minute to explain what insulin does and the role of the insulin. Right? And insulin is a hormone secreted by the pancreas. It does multiple things, but the major function is when it is secreted when the blood glucose level goes up. Typically, when you eat food, especially food with carbohydrates, your blood glucose level goes up because glucose is absorbed from the small intestine and so on. The pancreas secretes it, detects this and then secretes insulin. And the job of insulin is to shove this excess glucose into the cells. Yeah. Primarily the muscle cells, fat cell, and liver cells. Like this is the primary responsibility. And the good analogy people often use is a lock and key. Insulin is like the key that opens the cell's locks, and then it allows the glucose to enter. Right. So now coming back to carbohydrate insulin model, the explanation that people have for why people are putting on weight is, first, it is not the human's fault or the individual's fault, but why it happens is we eat a lot of high carb food, right, and that causes sharp insulin, sharp glucose spikes, and which again causes insulin levels to go up dramatically. And we do this very frequently, like we snack very frequently. So your glucose levels are perennially high, which means your insulin levels are very high always. This leads to insulin levels being chronically high. So this is the first step in the process. Your insulin levels go up. And because your insulin levels go up, any further new food that you consume, insulin's job is to shove it into your storage. So it prioritizes storage. So it shoves it into the fat, and so it takes away energy from the body. And so you tend to like eat more.
So let me just maybe just my understanding of that, Santosh, is, so if let's say you eat a food on one hand which is absorbing very slowly, which means your glucose levels are rising slowly. So enough insulin comes in, it shepherds that glucose molecule into cells for biological function, and slowly more energy comes in. It is shepherded into the relevant cells. But if it is carbohydrate rich or sugar rich food, then all that glucose is kind of dumped into your blood immediately, and the insulin spikes happen, and its body cannot consume so much energy. So therefore insulin has no choice but to take that those energy out of your bloodstream into fat cells for long-term storage. So while you consume a lot of energy, you may still not feel very energetic, because the energy is removed from your bloodstream and stored as a fat, and that's tiny bit of weight gain and again.
This is in summary the carbohydrate insulin model. Insulin levels are chronically high, so any energy that comes in gets shoved into your fat cells, which creates a vacuum almost in the body. Like, I'm feeling again hungry, I'll eat more, and then that is the reason why you are eating more. So it shifts the blame away from the individual to the fact that you're eating a lot of high carb food.
And this is also related, I think, practical tip here is, when people eat very fiber rich food, then you feel satisfied for a long period of time. But if you have a bag of chips or 5 cookies, you may feel great for 30 minutes, but an hour later you'll again feel hungry because all the glucose is out of your blood system.
This is the summary of the carbohydrate insulin model. Now, I'll talk about while this explanation is all good, there are, if you actually look at a lot of scientific studies done to verify the carbohydrate insulin model, the classic study is here, I think it was probably 1 or 2 years back. It's called the Diet-Fit study by Christopher Gardner from Stanford. And it was a fairly well-designed study. I think it was about 100 people, fairly long-term, almost a year, where the macro composition is very different. Whereas they prioritized mostly whole food, but it was a choice between a low carb food, a low carb diet versus a low fat diet, and the glycemic loads of the two were very different. So the low fat diet had high glycemic load, whereas the low carb diet obviously looked.
Okay, let's explain glycemic load also, and then we'll come back to this point.
Glycemic load is basically the glucose spike that you get after you eat. If it is very high, glycemic load is very high. Whereas if it's a very small spike that you get after eating, then the glycemic load is low.
And maybe let's explain, I think these days this awareness about glycemic load is also increasing, and people are using this
CGM,
continuous glucose monitor. So just can you explain what are CGMs, how do you use it, what and how can it help you develop some understanding? We'll come back to Stanford study, but let's finish CGM.
Right. So if you wanted to figure out what your current blood glucose level is, there is a ideal range for it. It holds around 100. It needs to be around 100, 110, and so on. Traditionally, we are using the finger prick, right? And you prick, and then you have this in. And now we have a better way to measure that on a continuous basis, which is the CGM, continuous glucose monitor. Comes as a patch. You put it on your arm or on your waist, and it has a needle which monitors the subcutaneous, the blood flow, and then the science of it we can discuss. But what it lets you do is every 15 minutes you can get a reading of what your current blood glucose level is. And how it is used for this, you can figure out what kind of food is causing what kind of blood glucose spikes for you. It is useful, but there are also caveats to it. It is one of the signals that the body uses. It is not the only signal, which is the primary criticism against CIL. Yes, glucose load is an important signal, but that is not the only thing that you should be looking at. There are many more things also.
Right.
But for people with diabetes, this is an insane tool. Like in terms of, earlier it was finger prick. Now you can do this continuously, and you can come up with much more actionable insights on what behavior changes you need to do, what kind of food you need to. Because glycemic load there is far more damaging. Because once you get into diabetes, and if you don't control your glycemic load, or if you don't control your blood glucose level, you can end up damaging your beta cells in the pancreas. Beta cells are the cells that secrete insulin, and you only have so many beta cells. And once they die, it's hard to, they don't come back. So for multiple reasons, for diabetes, this is an invaluable.
But even for people who are healthy or who have a tendency to gain weight, CGM is probably a good tool to just develop a good understanding of how food is affecting my, because people also react differently. Like same banana may cause, more glucose spike in me than you. And being aware of that is useful, while grapes might do, reverse. So being aware of, what causes more glucose spike and therefore insulin spike.
As a general guideline, yes. Again, the caveats are where it is important.
Sure.
I'll give a caveat.
Sure.
My own personal CGM experience. South Indian, I consume a lot of idli, dosa, etc. And idlis for me cost a lot more spike than ice cream. Right? And that's because ice cream, the amount of fat that you have, accentuates the blood glucose spike. If you use that as the only way in which you make your food choices, then obviously you cannot overconsume idli. Like it is, I have a 3-4, but I love ice cream. I can overconsume. And if I were to optimize just that one number, then I would be making wrong choices.
Okay, fair enough. So CGM is a possible tool. I think you're saying is much more relevant for people who are pre-diabetic or diabetic. But occasionally, people who have curiosity about how food affects them, they can also use it, probably not on a sustained basis. Okay, let's come back to this diet-fit study Stanford.
Study they took a large number of people for 1 year and then gave them 2 different diets, a low-carb diet and a low-fat diet. And at the end of it, the weight loss results were identical. Statistically, there was no difference between the two. Right? So, what again the takeaway here was, if glycemic load and the insulin hypothesis is the reason why people are putting on weight, a low-fat diet should have had a lower success rate than a low-carb diet. That was not the case.
Got it. And there are other studies also with similar findings?
Good meta-analysis done by Kevin Hall, which has looked at a bunch of studies which have done a similar kind of RCT. And even there, most of the studies, I think it was almost 27, 28 studies he looked at, and most of the studies when calories are matched, the macro proportions don't matter. That's the takeaway.
That's super interesting. I think I'll also look into in more detail, but from what I'm understanding, so you see last, I think 20, 30 years, this carbohydrate insulin model has been probably more mainstream model. There are a lot of best-selling books around that, and I think today anyone who's any curiosity about weight loss probably heard that eat foods which have low glycemic load, so therefore more fibers and more protein, more fat, and less sugar, less carb. Which has some relevance, but if it is matched calorie for calorie, some of these other studies shows that it does not really lead to a significant change. It may still be, probably it trains your insulin regulation better. So there's a benefit to it, but it may not result into weight loss.
And just go back to a previous point, which is the takeaways between both the models are identical. Like if you look at the energy balance model, it will again say the same kind of takeaways. Eat more protein, eat more fiber, and eat less refined carbs, etc. But just what exactly
the science
happens in
of
the
it,
body, right? That is where it differs.
Right.
So the takeaways that you mentioned in terms of what the CIM says, those are valid takeaways.
Right.
And those are things that you need to follow if you have to lose weight.
Right.
It's just the mechanism of it that is very different.
Okay, so let's discuss then let's come to energy balance model. When did it start to gain traction, and what does it say?
So this has been, both the CIM model and energy balance model have gone through multiple evolutions. More recently, a good formulation of it, I think there was a paper that came out in 2021, which says the energy balance model, beyond calories in and calories out. That was the name of the paper. It was by Kevin Hull. The short summary of the energy balance model is, it is still a energy mismatch that is causing you to gain weight.
Yeah.
And what is different is, a lot of it is beyond the individual's conscious control. Right? And what is happening is, your brain is the central organ which is responsible for managing your fat in the body, and there are genetic and environmental changes that explain what is happening in the brain. This is and that is what is causing people to gain more weight in the last 20-30 years. That's a very short explanation, but it needs a lot more expansion because this is slightly more complicated.
Yeah, so let's get into it. Yeah, we're discussing science of weight loss, so discuss in detail.
I mentioned earlier the central organ for weight loss here, according to the energy balance model, is the brain. And because I've been generally curious about weight loss, I've read at least probably 25-30 books around weight loss, right? And my biggest aha moment or the thing was this book called The Hungry Brain by Stephen Kinney. And he goes into a lot of detail explaining the energy balance model in the book. Now, the hypothalamus regulates multiple things, including the body's weight, right? And if you look at next level of detail, like what exactly is happening, a lot of it boils down to your eating behaviors, right? And there are two kinds of eating behaviors: what is called the homeostatic eating and non-homeostatic eating. Right? Homeostatic eating is eating for hunger, which is what your body needs. You feel hungry, for your body to function, you need to eat. Right? And that is homeostatic. Non-homeostatic eating is non-hunger driven eating. Right? And the short explanation is, non-hunger driven eating or the non-homeostatic eating has gone out of whack in the last 40-50 years, and that is what is causing the obesity pandemic. Now, just to complete the full picture, what is homeostatic eating and what is non-homeostatic? Both are kind of related and feed into each other also. Homeostatic eating is, again, further broken down into short-term and long-term. Short-term is, your body knows that when you start eating, when to stop eating. And it is again largely governed by the brain. That's an interesting part, which is, we think intuitively like, once our stomach becomes full, we'll stop eating, but that's not the case. Our stomach's capacity is much larger than what we typically eat. What happens is, you lose motivation to eat. When you start eating, by the time you finish eating, you lose motivation to eat. And that is largely driven by the brain. And this happens via the satiety mechanisms that happen So the short term, in summary, how it works is, you feel hungry. That is done by ghrelin, the hormone, and then you start eating. And once you start eating, your body starts absorbing the nutrients, and then your gut signals to the brain. There are two things that happen. Yes, there is some amount of that stomach expansion that happens. That is a signal passed to the brain. And what also happens is, in your gut there are a bunch of neurons called the neuropods, and that signals to the brain, saying it is actually nutrient sensing. It can recognize how much fat is there, how much protein is there, how much carbs are there in the food that you're eating, and then it signals to the brain.
So when people talk about the brain-gut connection, it's sort of about these neuron signaling.
Yeah, neuron signaling. And so it both of the signals is processed by the brain. There is also one more signal which the brain processes, which is the reward value of the food that you've eaten, right? Which is almost like and this is partly related to the non-homeostatic, but it is also an important signal which the brain takes, which is based on how much how calorie dense, how rewarding is this food, right? So that also is an input. So all of this inputs kind of comes to the brain, and it takes a decision. Okay, you need to stop eating now.
Rewarding in terms of just more sugar and carbs, or rewarding in terms of nutritiousness?
More in terms of the reward that I'm talking about here is more sugar, carb.
Right.
And we can go into more detail when we cover the non-homeostatic system, because that's where this comes into a lot more play. But it is a factor in determining satiety. Is what so you feel full, and then that is satiation technically. Satiation is end of meal, and then satiety is how long you end up feeling full before your next meal. Both are important. That is the short-term weight regulation, which is governed by the brain. There's a slightly more long-term regulation by the brain again. This happens via leptin. And we discussed that in the past. Whenever leptin levels go down, the brain starts doing counteractive measures. So this short-term and long-term regulation is what forms the homeostatic system of the brain. You need to know when to stop eating via satiety, and what should I do if I sense overall your body is not getting enough energy, which is the leptin signaling. Right? So far, all good. Like if this is what our bodies evolved for and is good at doing for all these years. Right? But what really changed is the non-homeostatic side, which is there are multiple buckets there, but the top ones are what is called reward eating or hedonic eating. Right? Again, caveat: it is not blaming the individual. It is not saying you crave for something and your conscious brain is doing that. No, it is more nuanced than that. But in short, what is this? It is what are called hyper palatable foods, like foods which are engineered for maximum dopamine hit. So and in the food industry, this is called the bliss point, right? And this came up in the 70s, 80s, where people figured out what is the most rewarding food, and it's usually a mix of right amount of sweetness, right amount of fat, and right amount of salt, and also a little bit of umami. Right, all of it put together is where you hit the bliss point. Right, and the food industry has cracked this, and they actually go to the level of like testing people with fMRI, saying like how is the reward system of the brain reacting to the food that you eat and so on. So that is a well engineered to make you overeat. Let me put it that way. Right. Which is right. And the mechanisms of this is largely driven by the same dopamine system. It is no different from your drive for sex or your drive for the social media. The same reward systems are at play here also. Right. And it happens at multiple levels. Like when you eat something very tasty, there is a signal that comes directly from your taste buds to the brain. And more interestingly, your gut also senses it. When gut senses the right amount of fat, and the interesting thing here is it is not just sugar. Like you cannot overconsume sugar, nor can you overconsume fat. It is the right amount of sugar and fat where the bliss point hits it, right? And a practical example, like what is anything tasty that you take will have a good amount of. They take chocolate, if there's enough fat. They take pizza. Anything that bypasses your typical reward behavior will have.
And this is a super important point. So I want to also emphasize. See, if you think of anything that you really like and crave, whether it's a chocolate chip cookie or Lay's chips or like very exotic flavors of ice creams, these things don't occur in nature. Like you cannot go to any tree or a field, right, and or an animal and get these things which are so tasty. So they have been designed by decades of scientific research, understanding exactly the reward mechanism of brain and exactly right combination of salt, sugar, fat, and umami in some case. Right? If you took a Snicker bar, it just tastes so good because it has all of this in it. So this is the battle that all of us as individuals, we have biology which evolved over this, mostly eating stuff that is growing on plants or animals, and now we have this factory manufactured things which are just like the I guess our apps on social media. The food is also engineered to stoke those deep cravings, and then no wonder we feel helpless in front of those cravings.
Exactly. And in the Hungry Brain, he explains and he draws analogy to the Daniel Kahneman system 1, system 2 thing. Like most of this is actually system 1, which is it is not under your consciousness, right? Which is these are like parts of the brain which were evolved long back before the system 2, the prefrontal cortex came in, right? And the another analogy people use is the elephant and the rider, which is the Switch book in Daniel Dan Heath, etc. say. Most of this is the act of the elephant, right? And you cannot blame the individual for it, the rider for it. When you have a hyperpalatable calorie dense food in front of you, it is just your biology that you just go for it and you have it. And once you have it, then there is the habit formation loop also that keeps in. It's just once your body senses that this is a dopamine triggering food for you, and then it remembers a lot of things around it. Like what is the context in which I got it, what is the smell of it, what is the texture of it. Next time the same thing happens, you just go on autopilot, right? And it's beyond conscious control.
And this is when advice like Michael Pollan has a lot of good books. He says like eat it if it grows on a plant, but don't eat if it is made in a plant. Plant as in factory. Right. I think that's one choice. I think I personally made almost 15 years ago. I almost don't eat anything processed now. Just don't. If it comes in a bag, sealed with preservatives, very rarely maybe for indulgence, but that's just not food. It's something engineered to stoke those cravings. And it's probably impossible to, even if you buy a lot of fruits from the supermarket, how many mangoes can you eat, right? Even if it's very sugary. Right. So I think that probably one big change that can what you're calling this non-homeostatic eating. If again, this change is probably going to be very hard. Anyone listening to it, I don't think you can switch on the flip on that switch tomorrow. But just being aware of this, if in your life, whatever calories comes from this engineered packaged food, if goes down, it can probably do a lot to restore balance with this energy balance model. So let's just come back to that. Let's continue.
And just on that point, the most actionable tip there is environment design. Like you have control for designing what environment and if you carefully put that's the strength of your system to thinking. Right? You can, when you are in control, when the system one is not in control, when the rider is in control, how can you pave the path for the elephant to walk in? How can you design the environment around you when you that is the best tip.
I want to share one example of the environment design theory. So at some point, sometimes I have meetings here and guests and so on. I start stocking some of these, packaged food like masala cashews and jeera cookies and so on. And then whenever I'll feel a little low doing the low energy, I'll just walk up the drawer, have. And a few months ago, I decided to just get rid of all of those completely. And after that change, I still have those cravings, but there is no ready option available, and then my consumption has gone down dramatically.
A very similar example happened at the cult office, which is earlier in our pantry, we had cookies. We continue to have cookies, but it was kept very visibly, right? And I had the same problem where between meetings, especially after some stressful meeting, I'll just go and take 3-4 biscuits and start having it. And you cannot say no, we cannot have this cake also. So, but instead, I suggested a small tweak. Let's not keep it on the make it very visible. Let's make it less visible. Keep it on the shelf on the wall, right? And I did it like a true product manager, before, after, pre-post, measured it, and we cut our biscuit consumption as an office or the cookie consumption by 60%.
60%
by just moving it 5 feet. Like
That's incredible. So it's a great example of environment design, right? So anyone who is either struggling with weight loss, or a parent worried about the weight gain among kids, or a manager, like what are the environment design changes you can make? It could be as simple as moving something from top shelf to bottom shelf, or in the behind row, or locked away in the cupboard, or something like that, or preferably just getting rid of from your house or office, right?
Now, the second kind of non-homeostatic eating, very commonly prevalent, is comfort eating, which is because of the kind of life we are in, anxiety, stress, etc. We go for coping mechanisms, and a very commonly used coping mechanism is food, because it is comforting, and that is not again driven by hunger. You do it because you want to compensate for something else in your life, and not the right way to do it. So that's broadly, there are other things, but broadly these are the primary reasons under non-homeostatic eating. The biggest bucket here is hedonic eating. This is food, engineered food. So the summary of this, the whole thing is, your non-homeostatic eating is increasing your set point. You're consuming more than what your body needs, and that is largely due to the environment. Right? Our food environment is so optimized these days. Access to high calorie, hyperpalatable foods is everywhere. Like, take an example. Like even when I was a kid, or we were kids, we used to look forward to festivals because that was the time where we have sweets.
Yeah.
But now that charm is gone.
Yeah.
Like any day you want sweet, you want to have or craving for sweet. It's just a matter of open your.
It's reverse now. Like when the festival approaching, you remind yourself that I'm not going to have sweet because they're having them throughout the year.
Exactly. That's because the access to sweets is dramatically low. Just a click of a few buttons on your phone. 5 minutes later, you'll have your sweet at your door, right? And that's what has changed.
I know I'm supposed to like role model, better behavior, but I did order some sweets on Swiggy yesterday after many weeks. But yeah, and I had a particularly stressful day. So at the end of the day, I just wanted to feel better. So yeah, and you're right. You just, pull out your phone, couple of taps on Swiggy, and there's nice mithai from Anand Sweets is, right there for you. Yeah. That's the example of, the coping mechanism, right? Yes. If I had a better day, then probably I wouldn't have done that.
Exactly. Yeah. So this is what the food environment has changed. We evolved in a particular food environment. The food environment now is engineered for overeating. And that is what has changed. And a lot of it is not under conscious control. You do it under just autonomous systems which are evolved long back. That is causing your set point to go up.
Right.
And then your homeostatic system kicks in and then defends against that set point. Right. So this is what is causing the obesity pandemic. There are other reasons. There is carbohydrate. The insulin model also has a role to play. There is hormones also have a role to play. But they are a minor reason. The major reason is this. Is what the current scientific consensus is.
Okay, cool. So Santosh, we discussed these two different models of why obesity is such a challenge. Carbohydrate insulin model, which has been more prevalent, but also this energy balance model. The eventual takeaways, what we need to do are similar. We'll probably summarize in the end. But the mechanism, like whether it is mostly because insulin sensitivity and glycemic loads, or it's because in some way retraining the brain around the set point of the weight, what's the root cause. So weight loss has by and large been an area of struggle for most people, and they've been one fad diet after another, even promising treatments and so on. But last 4 or 5 years, there is this massive hype around the class of drugs known as GLP-1, and the impact seems to be real. Like people are able to lose anywhere between 15 to 25% of weight and retain that weight loss. So let's talk about that. First of all, what is GLP-1? Is the hype real? And how does it work?
GLP-1 is a naturally occurring hormone in the gut, right? And it is what is called an incretin hormone, right? And this is closely related to what was called the incretin effect, which was first discovered in 1960s, I think. Incretin effect is basically this: like your insulin response. Your body responds to insulin when there is glucose in the blood. Right? Responds to insulin. What they did was, like, is there a difference between orally consuming glucose and injecting glucose? Like, how is the insulin response? And they figured out orally consuming glucose had a better insulin response than injected glucose. And they're like, how does it matter? Like, there is glucose in the blood. Pancreas should respond to it. Why is it responding different when it's orally consumed? And that was called the incretin effect. And then people started digging more and more, and then they discovered GLP as a naturally occurring hormone in the gut. That explains this. What GLP does is, it does multiple things. We can primarily 3 things, right? And the first one is, it in addition to pancreas getting signals from the blood itself, saying blood levels, sugar levels have gone up, and so we should release insulin, it further detects the glucose presence in the gut, and then again nudges the pancreas more, saying secrete more insulin, right? And so it almost like it is one more signal to the pancreas saying secrete more insulin. Yeah, that is one of the primary functions of GLP-1 in the natural. Second is gastric emptying, which is the speed at which the food should pass through the small intestine, and controls that. Third, which is the most interesting thing, is it seems to have some effect on the brain, right? And again, via the gut-brain axis, it signals to the brain and on satiety and when you should stop, and both satiation and long-term satiety, right? And this much was, and the last one actually was discovered very late. The first, the insulin thing was very clear. Immediately people figured out, okay, this is what is causing the extra insulin spike when you eat something orally, right? And that was but the interesting thing about first use of GLP-1 was for diabetes. So the people thought this becomes, what happens is it makes the body release more insulin, right? And so can we use this as a diabetes medication? That was the first thesis for GLP-1. And the thinking is this: like if someone needs extra insulin, and if you just inject insulin, right, which is what typically medication does, it is a very crude therapy, right? Because you can get into, you need to time it exactly right? Which is you need to if you get more insulin, then you can get into hypoglycemia, for example, and so on. So it's a very crude, blunt instrument, right? Whereas a GLP-1, let's say you increase the level of GLP-1, it is what is called the glucose moderated insulin response. So GLP-1, if there is glucose, then it will tell insulin, the pancreas increase insulin. If not, it will just keep quiet, right? So then it becomes a more targeted way in which you can increase the insulin levels in your body. So that's where it first got interest, and it was designed as a diabetes medication. And its first approval, all of it happened as a diabetes medication. There is a little bit of history also, like what is your naturally occurring GLP-1 is a very short-lived thing, right? And the evolution of why now this has become blockbuster is also closely tied. It typically lasts for 2-3 minutes only, the effect of it in the natural. But then people try to figure out how to increase the half-life of that as a medication. That's what has taken the last 20-30 years. Now we have a injection which can last for a week. Right? Now coming back to diabetes, right? And first it was launched as a diabetes thing. Even when people were, and it worked really well as a diabetes medication. And I think now the American Diabetes Association has changed this as a primary treatment for diabetes rather than an insulin injection. That's the recent guideline, probably 2-3 years back, because this is much more targeted and a better way to. But what people figured out during the studies of diabetes, that there was the side effect of people losing weight. Like, okay, this is interesting. Then can we do study this more? What people try to figure out. And then that's when the multiple things, like the first generation of GLP-1 drugs, multiple generations, the one most prominent one was called the liraglutide. This was launched in early 2010s, I think 2012, 2013, by Novo Nordisk. And that was primarily for diabetes. It is approved in US for diabetes long back. In India also this is available. And it also causes weight loss. With the right amount of dosage, it causes anywhere from 5 to 7% weight loss as long as you continue taking it. But then people thought, how much more juice can we get out of this? And then they kept working on it. The two ways, like increase the dosage of GLP-1 and increase the half-life of it. These were the two ways in which people figured out. There is a third thing also in action, which is the earlier liraglutide. The third did not cross the blood-brain barrier. It was not hitting the brain, right? Whereas the latest generation, which we will come to next, semaglutide, that seems to cross the blood-brain barrier. And summary of it, like the new breakthrough that came was the next generation of GLP-1, which is called the semaglutide. And again, this works for diabetes, and it was launched for diabetes. The diabetes medication was called Ozempic, and that's, I think, now very commonly known. And then the landmark trial in this was called the Step 1 trial, and this was published in early 2021. First time that it caught my attention, where I've been tracking weight loss of this thing. And the results were like astounding, to say the least. Right? Just it was a very long-term study. I think it was a 68-week study, which is people were put on 1 year plus another another 6.
This was done with Ozempic.
With Ozempic, and with the different variants of it, the dosage of it, etc. But net the takeaway was people on average lost 50 to 80% of their body weight in 1 year. There are some early side effects in the first few months, where nausea, etc. But beyond that, once people get past that, then no major side effects. And at the end of 1 year, this was a RCT, randomized control trial, and end of it, the weight loss difference. They compared it against gold standard, which is intensive behavioral therapy, which is diet consultation, blah blah. That typically gets you 5% weight loss, whereas this resulted in 15 to 18%.
Right. So just to summarize this one, right? So Ozempic is an injection that you take once a week. It works on your brain satiety signal. You basically feel less hungry, or when you start eating, you feel full early. As a result, people naturally consume less food, and you are able to drop weight, and really no behavior change. I mean, I guess some behavior change can enhance the effect, but even if you don't do it automatically triggers behavior change in terms of just eating less and less hedonistic eating and all of that, right? And this, from whatever we know, this is probably the most successful weight loss drug. And now I think the hype machine around this is getting into overdrive.
Right.
Like many other pharma companies are also working on competing products. I think some trials are being planned in India as well.
Yes.
So is it like finally, do you think we are at a point where humanity can solve weight loss for good?
Yeah, I'm an optimist in this. I think this is real. Actually, the science of it looks very, very sound. And the finally proof is the pudding, which is like weight loss is real.
Yeah.
And we have never had success. I mean, weight loss drugs, magic pill for weight loss has been a 100-year history.
Yeah.
Like, with multiple things, including leptin. There was a lot of hype around leptin in 1990, where people thought a magic pill has come now, but none of it materialized.
Yeah.
But this is the first time where we seem to have what is closest to a magic pill.
Yeah, and there is as proof in the pudding. In I think these the semaglutides industries, I think crossed $15 billion. It's growing more than 100% annually.
Yes.
And recently I was reading an article in Economist which says next 10 years it can cross $1 trillion in global sales, which is probably the probably fastest or maybe the first ever drug to get to that level scale, because obesity is is mainstream pretty much throughout the world. Today, if someone has to take a semaglutide in India, is an option available, or you have to wait until these companies come to India?
Semaglutide is not available in India yet. I don't know if it is available for diabetes yet. I think probably the Olympic version of it might, but for obesity definitely no. But liraglutide is available. I know a few people who have started using liraglutide. Some companies which have started using liraglutide for weight loss. It does give you success in terms of getting to that 5 to 7%.
Yeah.
But not as good as the same.
Right.
But I think it's just a matter of time.
And I think I was also reading that semaglutide in general have other positive side effects. Can you talk about that?
Yeah. So multiple side effects. First, all-cause mortality goes down dramatically. Then subsequent studies confirmed it. Cardiovascular risk goes down dramatically. And again, this is all very... But it is becoming one of those wonder drugs. And as recent as last, I think 2-3 weeks back, there was news that it is helping slow down Alzheimer's. And Alzheimer's, by the way, is very closely related to dopamine. It is a dopamine function that degrades over time, and so movement, dopamine, very closely related, and so on. It seems to affect the brain at a very fundamental level, which we don't yet fully understand. But fundamentally, the reward mechanisms of that is one part of it. In terms of just managing the health conditions that we know, the other very surprising part of it is addictions. It is becoming more and more an addiction drug. People who take GLP-1 for weight loss, if they have other addictions, they seem to be better enabled to deal with those addictions. It could be alcoholism, it could be nicotine, or it could be even shopping, social media addiction. Everyone is saying, I'm more in control now. That's the general. So, and if you look at a more macro picture, a lot of the ailments in the society right now are also problems of abundance.
But there has to be some catch as well. I think it's probably fair to say that while GLP-1 drugs have been around for a while, semaglutides not been around for a long time. And so one biggest drawback is you have to be on it. The moment you stop, the effect goes away. So it's like taking statins or metformin. This is something, you sign the contract for the rest of your life. So that is still a big drawback. It's also quite expensive. I've also heard that, this whole thing of it affecting motivations can even, you may not even feel thirsty. And there are cases of people fainting and so on. So I think there are probably some, it's, at the moment it's sounding too good to be true. There are probably other caveats which will emerge, as time progresses.
Completely agree. We don't know yet the long term, 5-year, 10-year, what are the side effects of this. But at the moment, short-term side effects, there are a lot of teething issues, but nothing major have come out yet. Agree on the cost of it. Right now, it is prohibitively expensive. In the US, it costs anywhere from $1,000 to $1,300 per month for you to be on this. Right? And, but I think one thing pharma is good at is playing the price game, and figuring out what is the right price. And there is also market forces that, after semaglutide, for example, there is tirzepatide that has come out, which Lilly has launched, and that is having even better results than semaglutide.
Is that one's commercially available or in trials right now?
It is past the trials. It was approved 4-5 months back for obesity in US. It is called Mounjaro. Is a brand name for it. Whereas semaglutide has a 15 to 18% in terms of the thing. This has a 20 to 23%. Now it is reaching bariatric surgery levels, which is 25% is the bariatric surgery, which is the gold standard for weight loss.
Yeah, so people who have who struggled with weight loss, I think they can definitely take a lot of comfort that these drugs are on their way.
Yes.
I think Ozempic, Wegovy from Novo Nordisk, and now this Mounjaro from Lilly. I think there are few more also. Pretty much every major pharma company is now trying to come up with something. Yes. So in all likelihood, in next 4 or 5 years, the whole range of options should be available. Yes. People who are really curious about India, my understanding is, I think Lilly is working with Dr. Reddy's to try to launch something in India in 2025 or 2026. It's just a matter of time. It's probably 1, 2, 3 years. Some of these drugs will be available. Probably going to be very expensive initially. But at least there is a hope.
So the short-term side effects, I think one more side effect which we should call out, which is often missing, is muscle mass. Muscle mass. I think the first trial, that the step-on trial, semaglutide, typically any weight loss that people undergo, you lose both fat mass and lean mass. And the idea is always to try and preserve your lean mass. You should try and lose only fat. But the first semaglutide had more than usual in terms of muscle mass. And so that rang a few alarms saying this is not healthy, there's not healthy weight loss, etc. But I think subsequent tirzepatide, for example, is not that alarming. And if you look at general practice, how people are using it, etc., if you combine GLP-1 with some resistance training, then you can preserve most of your lean mass. So it is still not alarming, but that is one myth that keeps coming up, saying you lose muscle also.
Yeah. And so in Indian context, you can't go to your doctor and get semaglutide tomorrow. You have to wait. But I think in preparation for that, people can still, things we have talked about, may start to make some of the permanent behavior changes. One is, I think even if you get into semaglutides, resistance training is a good idea.
Yes.
So please get active, just do movement. I think the way I look at workout is only two things. Do something where your heart rate goes up, and do something where you're applying resistance against your muscles. Yes. Whether you're in gym or a playground or at home doesn't really matter. So that's absolutely no-brainer move. Other is, I think what we talked about, there's over-engineered food. Yes. If you can slowly and systematically remove even some of them from your life, that will help, right? Yes. And then enhance some of those behavioral changes with the semaglutides, and you can have your ideal weight. If you are ready to take a drug for rest of your life, which again, I don't know, may not necessarily be the best idea, but at least that's on the horizon. Yes. But, so speaking of that, let's also talk about the rise of obesity in India. See, India, if you go back, 30, 40 years ago, the typical image of India in any small town was this like really lean, shriveled, people, like just with loose clothes and so on. That was India's, in 80s, 90s. And suddenly, now see, people all around are gaining weight. I think more so in cities or some parts of country like Punjab, Haryana, Tamil Nadu, Karnataka and so on. What has changed in the last 20, 30 years? Why suddenly we have started to gain weight at an alarming rate in the country?
I think same forces in effect, whatever happened in US. It almost seems like a side effect of prosperity, where once your food environment changes and prosperity comes in, you automatically put on that weight. But the problem with India specifically is, let me say, we should be extra careful as Indians, is we can't afford to put any extra weight, right? And that's mostly due to genetics.
Yeah, and on that, I think, I'd like you to elaborate. I think one of the statistics in preparation for this I was reading is, say, when US obesity is obviously massive, there nearly half the population is overweight, but the number of people with diabetes among the obese people only about 10% or so. While India, the weight gain is very directly correlated. Yes. Like as much as 60-70% of the people who are overweight. While even today the number of people who are overweight is a lot lesser compared to US, but among those who are overweight, the probability of diabetes is 6 to 7 times higher than that of US. Why do you think that's the case?
The explanation for this mostly comes from genetics. And, if you go back to fat storage, right, and there are two types of fat storage that your body typically uses. There is what is called the subcutaneous fat, and there is visceral fat. Right? Your body tries to first use the subcutaneous fat storage as much as possible. And once it runs out of space in terms of subcutaneous fat, then it starts accumulating as visceral fat. Visceral fat is fat around your organs. Subcutaneous fat is what is called the pinchable fat. Fat that is there in your
So basically just, if you like pinch your skin like this is the fat is here, this is the subcutaneous. And that is kind of uniformly distributed throughout the body.
Yes. And whereas the visceral fat is fat around your organs, around your pancreas, around your liver and so on. Now, how much subcutaneous fat capacity you have and when you run out of it is largely determined by genetics. And we have low subcutaneous fat capacity, whereas a Caucasian population has a lot more subcutaneous fat capacity. So what that basically means is we run out of fat storage very quickly, and so we start accumulating fat around our organs very quickly. So what this kind of means, subcutaneous fat is in comparison less harmful than visceral fat.
And just to so that people truly understand that, if you imagine a big American, they're generally big in size, tall, broad, like kind of uniformly distributed in all dimensions because they're carrying a lot of subcutaneous fat. While India, when people start to gain weight, for men, most of weight gain is around their belly, right? Or for women, belly and hips. So they may still be thinnish, but only in that particular part of the body. And this, you're saying that is because of genetics that are prevalent in this part of the world. It's how evolution panned out. But it's just kind of bad draw of the luck that while both fats are bad, subcutaneous is not that bad. But this visceral fat is really what's linked to diabetes.
Exactly. Yeah, that's the summary. So the analogy people use is apple-shaped fat or pear-shaped fat. Indians are more apple-shaped fat, whereas this Caucasian US population is more pear-shaped fat. And apple-shaped fat is just, you get into metabolic health problems very, very early if you're So what basically happens is you accumulate visceral fat around your organs, the organs functioning. Diabetes, for example, if you look at the mechanism of action where you end up this thing is, amongst multiple things, fat accumulates around your pancreas, which decreases the effectiveness of the pancreas, so it needs to do more work, which leads to multiple other metabolic problems. So basically visceral fat is very bad, and so there are studies which have done, and people say the typical BMI range 18 to 25 is normal, and 25 to 30 is overweight, 30 and then it gets into class 1, class 2, class 3.
Let's explain BMI also. We should have covered how do you calculate BMI.
It is body mass index. It is weight by height square, right? And adjusting for height, how much weight do you have? That's it is a rather crude measure of obesity. I'll explain because of the same reasons as or let me say crude measure of health. But it is okay. It is indicative, right? And the less than 18 is considered below normal. 18 to 25 is considered normal. 25 to 30 BMI is considered overweight, and then 30 plus gets into obesity. And there is class 1 obese, class 2 obese, class 3 obese. Earlier people used to refer to it as morbid obesity. That's not used in class 1, class 2, class 3, and so on. Now coming back to Indians, right? This guideline applies for a US population, but a lot of people, very good research in India done, say this guideline does not apply to India. For us, the cutoff is 23. Once you cross 23 in terms of BMI, then you're already overweight. That should be the guideline for India. And there is a recent, actually, there is a Health of Nation report which puts out, and they published the latest Health of Nation report, I think 2-3 weeks back. And one of the facts that they called out there was, first thing was 3 out of 4 people who come to health checkup at Apollo are overweight or obese, right? And that there is some selection bias there. People who go there are typically etc. But what is more interesting is the fact that they called out was people under 25 normal BMI, half of them have above normal visceral fat, right? So these are people who would, according to traditional BMI guidelines, we would say they are normal. Any excess fat for us will quickly get into metabolic health problems. We'll get into hypertension. We'll get into diabetes. So we cannot afford to put on weight. So
that's a huge concern for the country. I think anyone who is involved in health industry, policymakers, because what you earlier mentioned, the prosperity also brings abundance. Abundance, tends to food is available everywhere, and most of it is that, super engineered food. Both foreign companies, we have McDonald's and all kind of, fast food joints here, but a lot of also homegrown FMCG companies, keep creating, ever more irresistible flavor of chips and kurkures and whatnot, right? So, and all those numbers are increasing. As a result, we are likely to see obesity continue to increase, but we are probably going to get health-wise affected way more than the West, because we have the genetic propensity of the visceral fat increase. So, I hope, some people watching this, consider this as a serious warning sign. Otherwise, 5 to 10 years from now, the load on the healthcare system and the quality of life will go through. We feel this, podcast, we talk so much about, India century and, GDP going from $3 trillion to $30 trillion. But all of that is going to increase per capita income. And first set of things people start to consume is food and the abundance of that all around us. So it's a very, very serious issue. What is your input in how should both at an individual level and a society level we should orient towards what's going to come and prepare better so that we can limit the damage?
I think at a society level it is very hard right now because of the market forces. That is how capitalism works, and there have been some countries which have tried really hard to fight this systematically, concerted effort. US probably has not done that. I think Chile is a country where they took it very seriously, saying government really cares about this. We will bring about a lot of changes. So they tried to make the warning signs on the packaged food much more almost like how the warning signs on cigarette, etc. Make it much more pronounced. But none of them seem to have any effect. Again, because it is so hard. Biology of the body and the food environment is, you cannot just put a warning sign and go past it. Right? So I think at a society level, my large hope is right now GLP, if that actually helps. And but at an individual level, I think a lot can be done. Where if you follow, understand the mechanism of it, if you get to the usual things, which is right environment design, start with that. And eat mostly whole, nutrient-rich food, right? Bring in movement into your life, right? And make it a part of your life, etc. We have not talked enough about sleep and stress. Even those are equal contributors in terms of their effect on obesity. Typical good thing that you do for health, right? And on top of it, understand that how you are, your odds are against the food environment, and design your life carefully, right? And that's what you can do individually. That is well within anyone's control.
So let's also actually clarify that. How does sleep and stress affect weight gain?
Yeah. So on sleep, and there are a lot of studies done. There's one study which is very interesting, which is just one night of bad sleep. These are people who sleep. They made people sleep for 4 or 5 hours, as opposed to a typical 7-8 hours kind of sleep. The next day led to 30% extra calorie intake, right? And again, well-designed quality study. And the mechanism of action here seems to be, if you go back to the original analogy of elephant and the rider, what basically sleep does is the elephant becomes more powerful, the rider becomes less powerful, right? You just lose control of what is happening, and then you just start getting a lot more motivated to high calorie dense food. It is almost like a starvation response, a mini starvation response that the body immediately employs. So just getting high quality sleep is, and this is again well understood and well studied. Similarly for stress, chronic stress, cortisol goes up, and that has effects on insulin, and it also disengages the same mechanism that we talked about in hypothalamus, where the elephant is in a lot more control, right? And you also get into comfort eating, which is again something that we have discussed in the past. So both sleep and stress, underrated. People mostly focus on movement and nutrition, but if you don't pay attention to it, they become limiting factors. That is, you can be doing everything possible in terms of movement, but if you don't pay attention to your sleep and stress, then it will be a battle.
One simple way to just understand that, I think it's almost a given that we are going to be in an environment which is not conducive to healthy eating, healthy lifestyle. So it will require some willpower and control. But if you're stressed, or if you're sleeping less, then your willpower will go for a toss. It will be very difficult to control, your choices and actions, and you will give in to a temptation. So I think that's also an important part. Santosh, one thing we did not discuss is also a role of intermittent fasting. That's other thing which has gained a lot of popularity in last 5 to 10 years.
Right.
Where does IF fit in all these things? How relevant it is?
IF is a fantastic tool for calorie deficit. I think that's if you go back to the energy balance model, or how to lose weight, you need to be in calorie deficit. And what approach you as a person take doesn't matter. It's a personal, it's a preference. For some people, calorie counting works, and they're able to count their and intuitively develop an understanding of portion control, etc. And have what is called a moderation kick in, and so they're able to control and they're able to be stick with it. For some people, intermittent fasting works better because it is one decision which enables 10 decisions for you. Right? I will not eat between this time to this time, and then you are not in the constant battle of should I eat this, should I not eat this, etc. Or should I stop here, should I control myself, etc. Rather, it's a simpler decision framework for a lot of people. So that works.
Yeah.
There are, by the way, if you go to, there's a third strategy which is more a macro adjustment strategy. Anytime you go to either low carb or low fat, both are valid paths to achieve a calorie deficit because protein is inherently more satiating. And similarly, if you go to low fat, and you again end up eating a lot more protein and fiber. Basically, both are inherently a lot more satiating. So that is again a choice that you can make. So you can either play with your macros, you can practice portion control, or you can practice intermittent fasting.
Yeah.
Whichever works best for you. And it's me personally, for example, right? And throughout, I skip lunch on most days. That's just easy for me because my days are filled with meetings. So the thought of food, it's easy for me as a system to work with not having lunch. Right? And I practice that as a form of, it depends on your life situation. Whatever is easy for you,
just sharing from personal experience. I've also, I think, tried pretty much all kind of diet permutation combinations over last 20 years. But IF, I think, works brilliantly for me as well. Now my eating protocol is I eat my breakfast around 8 a.m. and my last meal, I don't even know whether to call it lunch or dinner, around 4:30 p.m. So I have about 8 to 9 hour window of eating and then another 15-16 hours of not eating. And most days of the week that works. Sometimes I'll feel a little tempted and have something little kind of late evening snack occasionally. But I think what you're saying, the key thing is I don't think anything magical about IF except that it just makes decision making is very easy. And it's also, I should mention that I don't think it's very easy to get into IF because you have to change some habits, because we have this autopilot behavior, whether it's your morning chai or evening ice cream, whatever. So that habit change is going to be hard. It takes, whatever that usual 10 to 15 weeks of effort. But I think once you adapt to that, going through the struggle, then probably going back to the set point or the energy balance, then brain knows that this is my eating window. And you just don't feel hungry, when it's not your eating window. And it's quite miraculous. In fact, you start to realize that how much body's ability to generate energy, because we all carry so much stored fat, which is something, we all, because of continuous consumption, we never use that fat, but it's all there, for when you're not eating. So just, just coming back to the obesity and the rising epidemic of diabetes in India. So what you are saying is today, probably individuals have a lot more control. I think the picture at the society level is somewhat pessimistic unless something dramatic happens. See, even semaglutides, I don't know. I don't think, we can have 500 million people in India on semaglutides. The cost of that is going to be just, unaffordable. And until all these patents expire, in 10 to 20 years, all that revenue will also flow to, global pharmaceutical companies. So that's a solution for the rich maybe, but I don't think that's a mainstream solution. So we really have this big obesity/diabetes epidemic building up.
Yes. And it is the individual's choice now. Take control of it and start acting.
Right. So individuals is summarizing, right? So people can, what you mentioned, you can focus on environment design. You can make some lifestyle choices. You can consider IF. add some kind of cardio and resistance training, pay attention to sleep and stress, and probably, just ban processed food from your life if you can. I think by and large that should do the trick. And I think companies can do, because a lot of people, say part of environment for a lot of people is the company they spend time with. In Bangalore, startups, people spend 10, 12, even 14 hours in office. What role should company play in nudging? I also just want to share, I was recently invited by Deloitte Consulting for their partners meet, and they've created a role called Chief Happiness Officer. And they've mandated health checkups for everybody and said that is going to be part of a performance appraisal. If you have not done health checkup, then the highest rating is not even in consideration. So what do you think the companies can do in general to promote healthy behavior?
Yeah, this is definitely something that a lot of companies should pursue, and there are a lot of successes that have come. I think Zerodha, for example, had a very thriving fitness focus within their company, and they have spoken about it enough. Even at within Cult, I think I've heard a lot of stories where people's lives have changed after joining Cult as an org, because this is also part of an environment, right? And like you rightly said, people spend 8 to 10 hours in an environment. And if you see around you people who seem to be eating the right thing, and you who seem to be including movement as a part of this thing, then you automatically get that inspiration and motivation. And from the company side, prioritize health of the employees. That's a win-win. Like, the employees are going to benefit, and better health for employees and better productivity for the organization. There are a lot of interesting things you can do apart from just health checkups. A lot of gamification. I know we have tried this in the last 1 year and has gone really well. Where we have an initiative called Cure.fit within Cult, where we do a lot of gamification, contests, and regular periodic activities where we bring in movement as part of everyday work life also. A lot of things that companies can do. I am an optimist in that.
That's great. I hope, again, the senior executives listening to this podcast will probably consider taking some actions, within their organizations. I think with just small nudges and influence, they can create a lot of positive impact in a lot of people's life. Just going back to society at the country level, Santosh, I think, maybe you can think about creating some kind of white paper, collaborating with some of the other people who are deeply interested in this area, and we take those white paper to all the policy makers. So because people don't realize what is going to hit them in 5 to 10 years, and unfortunately healthcare system does not have the right incentive. If you prevent a lot of people from not gaining weight and not becoming diabetes, which brings whole host of other problems, there's a lot of downstream revenue of the healthcare system goes away, which is not good for the healthcare provider, but great for society. So probably there's something you can consider, writing a very comprehensive science-based white paper, and then maybe it will get attention of the policymakers, state and central level.
Sure, that's a brilliant idea. We'll take it up.
But it's great, Santosh. I think first of all, it's great that you have personally taken so much interest, read all those books and research papers and studies. I think this was a very comprehensive conversation about state of the art of science of weight loss. I think we covered both, what the latest science has to say, the rise of GLP-1 as a potential big solution, but also various lifestyle interventions that's available to all of us. So hopefully people will find enough useful takeaways and probably kickstart their own weight loss journey. Thanks, Santosh. At SparX, we aim to bring to you stories of exponential impact. We share in-depth analysis of what goes behind success stories. If you find our conversations interesting, you can join us by subscribing to our YouTube channel. You can also listen to SparX on Spotify, Apple Podcast, or any other audio platform of your choice. If you have any suggestions on who we should invite or what topics we need to cover, just let us know in the comments. We are always listening, looking for ways to improve, and keep getting better as we go along.